Welcome back to the Talking Ketamine podcast. This is episode 72, S-ketamine versus R-ketamine, the mirror image paradox.
Today we're exploring a mystery in depression research. Why does R-ketamine, a mirror image molecule 4 times weaker at binding to target brain receptors than S-ketamine, consistently produce stronger and longer-lasting relief? It's a chiral paradox that is forcing scientists to rethink how rapid-acting antidepressants actually work.
So, if you follow psychiatric medicine at all, you already know the bottleneck we've been stuck in for, well, basically 60 years.
Right, the whole monoamine hypothesis.
Exactly. We've just been tweaking serotonin or maybe dopamine and just kind of hoping for the best. And eventually, that approach just hits a wall.
It really does, especially when you consider that roughly 30% of patients are dealing with treatment-resistant depression, or TRD.
Right. And for those patients, playing that sequential game of trial and error isn't just frustrating. I mean, it's an agonizing, months-long waiting game, right? You wait 6 to 12 weeks just to see if a pill works.
And it often ends in diminishing returns. The more medications you try, the less likely the next one is to give you full remission.
Yeah, which is just heartbreaking. But the shift away from that waiting game didn't actually happen until researchers started, looking backward. They started reevaluating this old dissociative anesthetic that was synthesized all the way back in the 1960s. Ketamine. It was originally approved by the FDA in 1970 for surgery. But then right around the early 2000s, controlled data started emerging, and it showed that a single subanesthetic infusion could produce meaningful reductions in severe depressive symptoms.
Not in weeks either.
No, in a matter of hours, which completely shattered the psychiatric paradigm.
Hours, not months. I mean, we're talking about a true medical paradigm shift here. But as the scientific community scrambled to figure out how this old surgical anesthetic was pulling off such a rapid turnaround, they ran into a structural quirk.
Right, because the ketamine we've been using since the 60s isn't just one uniform substance.
No, it's not. And this is where we get into the realm of stereochemistry.
Which sounds super intimidating, but imagine looking down at your own 2 hands.
That's a great way to picture it, actually.
Yeah, because they are made of the exact same components. You've got your fingers, your thumbs, your palms, but they are non-superimposable mirror images.
Right.
Like you literally cannot stack your left hand perfectly flat over your right hand. They just don't match up that way.
Exactly. And that chiral nature, that handedness, is the foundation of this entire paradox. Because standard ketamine is what we call a racemic mixture.
Meaning it's a 50-50 split.
Right, a 50-50 split of 2 mirror image molecules that are created at a specific structural junction called the C2 carbon. We refer to these 2 enantiomers as S-ketamine, or S-ketamine, and R-ketamine, which is R-ketamine.
So we basically have a left-handed molecule and a right-handed molecule just coexisting in the same vial.
Exactly, coexisting and being administered together for decades.
Right, but to understand how they work in the brain, we probably have to put down the hands metaphor and think about keys fitting into a lock.
A lock and key model is perfect for this.
So currently, the FDA has only approved the S-ketamine key as a psychiatric treatment, right? It's formulated as a nasal spray.
That's correct.
But when you look through the preclinical data, scientists are starting to realize that the ignored R-ketamine key, the other half of that mixture, behaves vastly differently, which makes you wonder, if they were both sitting right there in the original mixture the whole time, why did pharmaceutical development hyperfixate on S-ketamine and just leave R-ketamine in the dust?
Well, it comes down to how traditional pharmacology operates. It relies on a very straightforward, almost brutalist logic.
What do you mean by brutalist?
Basically, you find the target lock in the brain, and you find the key that jams into it the tightest. Tighter binding equals a better drug. That was the assumption.
Okay, and what was the lock they were looking at?
In the early days of investigating rapid-acting antidepressants, the prevailing theory was that the drug needed to block something called the NMDA receptor.
The NMDA receptor, okay.
Right. And S-ketamine binds to that specific receptor lock with an affinity roughly 4 times stronger than R-ketamine.
4 times stronger. Wow.
Yeah. So if you are a drug developer operating under the assumption that NMDA blockade is the entire ballgame, a stronger binding grip naturally predicts a more potent drug.
It was a no-brainer for them to pursue the stronger molecule.
Absolutely. Why would you spend millions developing the weak key?
Okay, but I have to push back on that tighter is better assumption. I mean, if S-ketamine has this supposed stranglehold on the NMDA receptor, What is that actually achieving biologically? Traditional pharmacology says it wins, but what does winning actually look like inside a severely depressed brain?
Winning, in this context, looks like a massive, immediate biochemical disruption.
Disruption. Okay.
Yeah, S-ketamine acts as an open channel blocker. It forces its way into the NMDA pore and basically halts the flow of
So it
ions.
clogs the channel.
Exactly. And the brain instantly registers this blockade and compensates by releasing a massive surge of glutamate.
Oh, interesting.
And that glutamate surge then activates a totally different set of receptors, the AMPA receptors, which kicks off a rapid cellular signaling cascade.
Okay, so it causes a chain reaction. But what does that mean clinically for the patient?
Well, clinically speaking, the most crucial outcome of that aggressive blockade is the immediate suppression of a tiny, hyperactive brain region called the lateral habenula.
The lateral habenula, which is essentially the brain's disappointment center,
Yes, it's often referred to that way.
which is such a dark name for a brain region. But when someone is trapped in severe depression, this region fires pathologically, right?
Right, it becomes hyperactive.
It essentially punishes the brain by suppressing the release of crucial reward chemicals like dopamine and serotonin.
Exactly. And because S-ketamine has that vice-like grip on the NMDA receptor, it can shut down that pathological firing in the lateral habenula in a matter of minutes.
Minutes, not weeks.
Minutes. The clinical results of that pharmacological brute force are just undeniable. If you look at the Aspire trials evaluating S-ketamine, researchers documented statistically significant reductions in severe suicidal ideation at the 24-hour mark.
In just 24 hours.
Yes. At 24 hours, a standard SSRI is still entirely pharmacologically inert. It hasn't even started working yet. So when you were dealing with an acute psychiatric crisis, that kind of speed genuinely saved lives.
That's incredible.
Yep.
But here is where the rules of the game kind of fall apart for me.
How so?
Well, if S-ketamine stops the lateral habenula dead in its tracks and it pulls people back from the edge in 24 hours, why are we even talking about the weaker molecule?
Oh, right.
If R-ketamine is 4 times weaker at blocking that supposedly critical receptor, logic dictates it should be less effective. Yet the preclinical studies are telling us the exact opposite, aren't they?
They really are. They're completely rewriting our understanding of neurobiology as we know it.
So what changed? Who figured this out?
The real turning point was a 2016 preclinical study led by a researcher named Hashimoto. They were using mouse models of depression.
Okay, mouse models.
Right. They separated the mirror images and tested them head-to-head. S-ketamine versus R-ketamine. And despite R-ketamine's weak, almost negligible grip on the NMDA receptor, it produced antidepressant effects that were stronger and much more durable.
More durable, how much more?
Well, in the animal models, the behavioral relief from S-ketamine faded after about 3 to 5 days. The relief from R-ketamine lasted up to 7 days.
Wait, so it lasted almost twice as long.
Yes.
But wait, if the entire mechanism of action relies on blocking that NMDA pore to trigger the glutamate surge, how is the weak key building longer-lasting neural connections? I mean, it shouldn't even be able to start the engine, right?
That's the paradox.
All right.
But it turns out it doesn't need that engine because it's running on a completely different pathway.
Oh, really?
Yes. The field had tunnel vision on the NMDA receptor, but R-ketamine engages a unique intracellular chaperone protein called the signal-1 receptor.
The sigma-1 receptor.
Right. And S-ketamine has virtually no activity there at all. R-ketamine, however, engages it heavily. Furthermore, as the liver metabolizes R-ketamine, it produces a specific breakdown product.
A metabolite.
Exactly, a metabolite called HNK. This HNK metabolite entirely bypasses the NMDA blockade and directly stimulates those AMPA receptors to kickstart the healing cascade.
That is wild. So we were judging a drug's effectiveness based on how well it blocked a door, while R-ketamine was basically just walking through the walls to get the job done.
That's actually a great way to think about it. And what it gets done is profound. The combination of sigma-1 engagement and the HNK metabolite drives deep, long-term neuroplasticity.
Neuroplasticity, so like the brain's ability to physically change and adapt.
Yes, we really have to understand what chronic stress and severe depression actually do to the physical structure of the brain over time.
Right, it's not just a chemical imbalance.
Far from it. They cause the tiny branch-like connections between neurons, which are called dendritic spines, to literally shrink and retract.
Oh, wow.
It's like the branches of a tree dying back in a severe drought. The connections just wither.
That's a terrifying image, but it perfectly explains the brain fog and memory issues in depression.
Exactly. So what R-ketamine does, independent of the NMDA receptor, is stimulate the synthesis of synaptic proteins to physically grow those dendritic spines back.
Just regrow the branches.
Yes, specifically in key regions like the prefrontal cortex and the hippocampus.
Okay, so it's really the difference between a sprinter and a marathon runner?
The sprinter and the marathon runner. I like that analogy.
Yeah, because S-ketamine is the explosive sprinter. Its aggressive grip gives you that immediate biochemical disruption to lift a crisis in hours. But R-ketamine is the marathon runner.
Right.
It lacks that brute force, but by engaging the chaperone proteins and utilizing the metabolite pathway, it acts like like a fertilizer for the brain.
Fertilize, yes.
It repairs the structural damage at a sustainable pace, allowing the antidepressant effect to endure for a much longer period.
And keeping that sprinter's pace that S-ketamine has comes with massive physiological whiplash.
Oh, I'm sure.
The transition from lab data to the patient's actual lived experience
Yeah.
is where we really start to see the immense cost of S-ketamine's aggressive NMDA blockade.
Let's really look at that. Let's look at what blasting that NMDA receptor feels like for the patient. Because as a patient advocate, treating treatment-resistant depression isn't just about, molecular binding affinities.
No, not at all.
It's about the burden of care. And the pharmacological turbulence created by S-ketamine is, frankly, staggering.
The clinical profile is undeniably turbulent. The most prominent adverse effect is intense dissociation.
Right.
We're talking about a profound trip or a feeling of being completely detached from reality in one's own physical body.
Which hits what, 25 to 40% of patients?
Yes, roughly 25 to 40% experience this intense dissociation. And alongside that psychological turbulence, you see severe physical side effects too.
Like
Transient but alarming spikes in blood pressure, significant nausea, and severe dizziness.
which triggers a logistical nightmare for the patient. I mean, because of the cardiovascular risks and the intensity of that dissociation, the FDA enforces a strict risk evaluation and mitigation strategy, or IRMAS mandate.
The REMS mandate, yes.
You can't just pick this medication up at a pharmacy, go home, take it, and get on with your day.
No, absolutely not. The REMS mandate requires patients to travel to a certified healthcare facility, administer the medication under direct supervision, and remain trapped in that clinic for at least 2 hours of clinical observation until the side effects dissipate.
Which, think about what that demands of someone already flattened by severe depression. If you are a working parent, or you live in a rural area far from an urban clinic.
Or your insurance refuses to cover the exorbitant out-of-pocket costs.
Exactly. You are effectively walled off from this treatment entirely. And TRD isn't something you cure with a single dose.
No, it's a chronic condition. It requires ongoing maintenance.
But prolonged therapeutic courses of S-ketamine carry documented long-term risks.
They do.
We are talking about bladder toxicity, urinary frequency, severe pain, and potentially irreversible bladder fibrosis. Not to mention the potential stress on the liver from extended use.
It's a heavy toll on the body.
It really is. Which begs a critical question. Is that harrowing out-of-body trip actually required for the brain to heal, or is it just an unfortunate side effect that we've been forced to accept?
Well, for a long time, the psychiatric community was really split on that. A significant camp believed the psychedelic dissociative experience was integral.
Like, you had to have the psychological journey to break the depressive loop.
Right, the trip itself was therapeutic. But advanced imaging data strongly suggest it is just collateral damage from the NMDA blockade.
Oh, really?
Yeah. When researchers ran PET scans on subjects administered S-ketamine, they observed massive frontal cerebral hypermetabolism.
Hypermetabolism, meaning the brain is working too hard.
Yes, the front part of the brain essentially goes into overdrive, burning glucose at an unsustainable rate. That metabolic hyperactivity correlates directly with the intensity of the patient's dissociation.
So the brain is just revving its engine in the red, generating all this heat and turbulence, but not necessarily driving the actual healing process.
Precisely. Contrast that with what happens when they run the exact same PET scans using R-ketamine.
What happens?
They observe the exact opposite metabolic response. R-ketamine significantly decreases frontal glucose metabolism.
It decreases it.
Yes, it actively calms the circuitry down. And because it doesn't send the brain into metabolic overdrive, the preclinical behavioral models show it produces almost zero dissociative or psychotomimetic effect.
Almost zero. Wow.
Right. It drives the deep structural neuroplasticity, the growth of new dendritic spines we talked about, without subjecting the patient to pharmacological whiplash.
That is staggering. I mean, it means patients might not have to endure an exhausting, turbulent physiological gauntlet just to find a baseline of relief.
It's a huge shift in how we think about treatment tolerability.
If R-ketamine is genuinely calming the brain's metabolism while simultaneously acting as a fertilizer for long-lasting neural connections, it sounds like the holy grail.
Yeah.
It honestly makes me wonder if S-ketamine is just a crude stepping stone that is about to become completely obsolete.
That is a very tempting conclusion. But the neurobiology suggests a much more nuanced reality.
Okay, tell me why.
Well, these two mirror image molecules are not enemies,
Mm-hmm.
and they aren't competing for the exact same role either. They have vastly different jobs in the clinical toolkit.
Okay.
S-ketamine's unique strength is simply irreplaceable in an acute setting. It is the ultimate first responder for a mental health crisis.
Because of the speed.
Exactly. When a patient arrives in the emergency room in the throes of severe acute suicidality, you do not have days to wait for new dendritic spines to slowly sprout. You just don't.
Right, you need immediate intervention.
You need the pharmacological brute force of that strong NMDA blockade to slam the brakes on the lateral habenula immediately. Right now, no other approved drug can stabilize a crisis at the 24-hour mark like S-ketamine.
Okay, I see. It's the ambulance.
The ambulance, yes.
When someone is bleeding out, you need the ambulance with the sirens blaring to show up, break all the speed limits, and stabilize the situation fast, regardless of how turbulent the ride is in the back.
Right, the turbulence doesn't matter when you're saving a life.
But once you are stabilized and discharged, you don't use an ambulance for your daily commute.
That is a vital distinction. You don't. And R-ketamine represents the daily commuter vehicle.
The daily commuter, I love that.
It has the potential to be the sustainable, long-term maintenance partner. What is particularly fascinating about the animal studies on R-ketamine is its robust effect on anhedonia.
Anhedonia, the severe inability to experience pleasure, right?
Exactly, and profound motivational deficits. Those are the stubborn, lingering domains of depression that conventional monoamine drugs and even S-ketamine often fail to fully resolve.
Right. Patients often say they don't feel sad anymore, but they don't feel happy either. They just feel flat.
Precisely.
Yeah.
By lacking the severe dissociative side effects and that metabolic hyperactivity, R-ketamine holds the promise of being a much gentler, safer option for long-term repeated use, all without those grueling 2-hour clinic hostage situations.
We finally have the ambulance for the acute crisis, and we are on the verge of securing the safe, reliable vehicle for long-term wellness.
We are.
But anytime we use the phrase on the verge in psychiatric science, we really need to pause.
We do. We definitely do.
Because as much as anyone listening might want to call their doctor and ask for this tomorrow, we have to look soberly at where the research actually stands today, right?
Right. Scientific rigor demands a major caveat here. The vast majority of the data demonstrating R-ketamine's superiority, its durability, and its lack of side effects comes from preclinical animal models.
Nice.
Mice, exactly.
Yeah.
Now, the mouse data is incredibly robust and highly consistent across multiple independent laboratories globally, which gives us strong confidence in the mechanism itself.
But psychiatry has a long, humbling history of compelling rodent findings that completely evaporate when applied to complex human biology. I mean, we've cured depression in mice thousands of times, right?
Thousands of times. A mouse brain simply doesn't map perfectly onto the complex human experience of chronic depression.
It doesn't.
However, the translation into human data has officially begun, and the early signals are very promising.
Oh, okay. Tell me about the human data.
Well, a research group led by Lille conducted an open-label pilot study in humans in 2021, and they followed it up with a placebo-controlled pilot study in 2023.
Okay, recent. And what did they find?
Those pilot studies demonstrated that intravenous R-ketamine did indeed produce significant antidepressant responses in patients with treatment-resistant depression.
That's huge.
It is. But more importantly, it confirmed the safety profile. It produced a significantly cleaner, gentler experience with vastly fewer side effects compared to racemic ketamine.
But we have to emphasize that these are just two small, early-stage pilot studies.
Right. Very small sample sizes.
So what is the actual hurdle holding this back? What needs to happen before a patient can walk into a clinic and choose the marathon runner over the sprinter?
We urgently need large-scale, head-to-head, randomized controlled trials in humans. S-ketamine and R-ketamine have never been directly compared in a properly powered, large-scale human clinical trial.
Wow, never.
Never. Until those large RCTs are completed and peer-reviewed, the entire narrative around R-ketamine's clinical superiority remains an incredibly well-supported hypothesis, but a hypothesis nonetheless.
So we're just waiting on the data.
We are. Those trials are actively running as we speak, and the entire psychiatric field is holding its breath to see if the human data will finally confirm what the preclinical models have been shouting at us for the last 8 years.
It really forces you to take a hard look at how we define medical progress.
Also,
Well, if conventional pharmacology judged R-ketamine as too weak for decades simply because it didn't fit the expected receptor lock perfectly, what other miraculous, long-lasting cures are currently sitting in the discarded scrap heap of medical history?
that is a profound question.
I mean, how many other overlooked mirror molecules are out there right now, just waiting for us to stop judging them by a narrow binding affinity test? It's comforting to think that future treatments might offer the deep healing our brains need without the intense, turbulent side effects, making long-term recovery feel much more within reach.
Absolutely, Celine. By understanding the mirror image difference, we can move from simple crisis management to long-term brain maintenance and gentler paths to wellness.
A very hopeful look at the future of mental health. Thanks for listening to the Talking Ketamine podcast. We'll catch you on the next one.